So this is a mass percent concentration kind of question here. Now I want to point out that when we're dealing with these kinds of problems, the kind of problem you can be faced with can involve milliliters, as it is here, or it could be grams as well, and this one down here could be milliliters or grams as well. Now if it's mass percent we're looking for, then the mass percent, in this case we're looking for the mass percent of X, is going to be the mass of X divided by the mass of X plus the mass of Y. Now obviously if you're given the masses as grams, then you won't have to do as much here in this question, but in this case we're given them both in milliliters, which means we need to find the masses using the densities. And we know that density is mass divided by volume, so we therefore know that mass is going to be density times volume. So mass is X, mass of X is going to be density times volume. You have a density of X is going to be 0.806 grams per mil, multiplied by the volume, which is 30.00 mils. Accounting for significant figures, we're going to come up with 24.2 grams for the mass of X. Mass of Y, we're going to do the same thing. It's going to be density times volume. Again, 0.806 grams per mil. Same density, coincidentally. And 685.00 mils, which comes out to be 552 grams when we account for significant figures. So that's going to be the mass of Y. So if we continue on with now we've got these masses here. The mass of X is 24.2 grams. The mass of X plus the mass of Y, 24.2 grams plus 552 grams. All of that's going to be multiplied by 100%. Now the issue here is that since this is addition, it's going to go by the number of places past the decimal. So the sum of those two is going to be 576 grams with 0 places past the decimal. So when we finish this up and get the final result, it's going to be 4.20%, which has 3 significant figures because this has 3 sig figs and the 576 has 3 sig figs as well. And that means this answer here will have 3 sig figs.